and welcome to Dreamacademiá. This would be your second lecture on limits in your WebG crash course. So today we will be discussing about important series which are sometimes used to solve questions in limits. Okay, so actually there are a lot of series. We have given example of this 5 only, but these are the most common ones which you will be using when you solve questions. So sometimes you have to use this type of series in your questions, which you will understand as you practice more questions. So you should know the expansion. These are known as Maclaurin's series. It comes from Maclaurin's theorem, which you will learn in your higher classes in your graduation. But before that, you should just know how the expansion is. So for first is for e to the power x is 1 plus x plus x square by 2 factorial, so on up to infinity. It's an infinite series. Okay, infinite. And for e to the power minus x, if you put minus x in place of x, you get the rest. So you should memorize e to the power x series, so you can easily get e to the power minus x. Okay, now sin x. What about sin x? Sin x is x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial, all the odd terms. So sin x is I will tell you a trick to remember this, how I used to remember. So sin x is a odd function, so odd terms are coming. Okay, and cos x is an even function, as you know. So for cos you will get all the even terms, 1 minus x squared, or you will be taking alternative positive and negative terms. Okay, fine. Now the last one is tan x. Tan x is a bit difficult one, so it is advised to remember the first three terms, that is x cubed by 3 to x to the power 5 by 15. So you remember only the first three terms, it will be enough for you to solve the questions. Okay, now in the previous day we were discussing about the indeterminate forms of limits. So we discussed two forms, 0 by 0 and infinity by infinity. This is the third form, that is 0 into infinity form, which can be, you can see that, which can be brought down and reduced to the 0 by 0 or infinity by infinity form. So once you reduce the 0 into infinity form to either 0 by 0 or infinity by infinity form, you can apply L'Hopital's rule and you can solve the indeterminate form. Okay, fine. Okay, now next one. This is an important form. This is 1 to the power infinity form, and this is very important. A lot of questions come from this part. So in 1 to the power infinity form, as you can see that if how the 1 to the power infinity form is coming, first of all, you see that suppose you have a function f of x, and as x tends to a, f of x tends to 1, and as x tends to a, g of x tends to infinity, then f of x to the power g of x tends to 1 to the power infinity, which is an indeterminate form, and you can find out the result of the limit by using this formula, e to the power limit x tends to a, f of x minus 1 into g of x. This entire limit is in the power of e. Okay, so actually how it comes, there is also a derivation how it comes. This is not just a simple formula. We will not discuss it in this lecture. Maybe we will discuss that in the lectures of the normal classes, which we do, like in the normal classes. So now we will solve questions. Okay, so this is the first question. This is a very important question. Okay, let me say you, this is a very important question. Why? Because this type of questions comes in all sorts of competitive exams. You have to find the value of the unknowns using limits. So in this type of questions, whenever you see this type of questions, you will try to use not L'Hopital's, because e to the power x, this function, whenever you will differentiate, e to the power x will remain. Cos x also, cos side alternatively it will come, and e to the power minus x also. So in this type of questions, try to use expansions, which we discussed. Expansions or series. So this is a trick for solving this type of questions. So how we will do? We'll use the expansion of e to the power x, that is a 1 plus x square by 2 factorial and up to infinity. Then we will write the expansion of cos, that is 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial, right, up to 3 terms. Sorry, minus. Then we will write the expansion of e to the power minus x, which is 1 minus x minus plus x square by 2 factorial and minus so on. And in the denominator we will write the expansion of sin x. So we will get x into x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial. So okay, and it is given this entire limit is equals to 2. Okay, equals to 2. So now how we will do, since this is equals to 2, let me write down the terms first. Okay, we will write all the factors of 1, a plus b plus c. Then we will write the factors of x, a minus c. Then we will write the factors of x square, that will be equals to x square, and you get a minus b by 2 factorial 2. Okay, a by 2 also. What's that? A by 2, b by 2 plus c by 2. And you will get the higher powers like x cube, x is 4, x to the power 4, like this. Okay. So divided by, okay, so here you will get x square, x to the power 4 by 3 factorial, x to the power 4 by x to the power 6 by 5 factorial, so on. So so here you will get x square minus x to the power 4 by x factorial, so on, equals to 2. So since it is equals to 2, this means that the limit is exists. Okay, it is not infinite or infinite limit. So here whereas x tends to 0, this is equals to 2. Now you see, if I divide the terms by x square, okay, so you can see that here the lowest power, what is the lowest power of x? X to the power 0. So if the limit has to exist, the lowest power of x has to be x square. So that if you divide both the numerator and denominator by x square, then what will happen? The lowest term will remain and all the rest terms will become equals to 0, and you get the value. So lowest term has to be x square. So what will happen? X to the power 0 का जो coefficient होगा a plus b plus c, that has to be 0. Okay. X का जो coefficient है, that has to be also equals to 0. So a equals to a minus c is equals to 0. So a equals to c. And this one, the coefficient of x square has to be equals to the limit, which is 2, because all the rest terms will become 0 and only this term will remain. So a minus b plus c by 2 is equals to 2. So this is equals to 4. So this is your equation 1, this is your equation 2, this is your equation 3. After solving all the three equations, solve. After solving, we will get a equals to 1 equals to c and b equals to 2. Okay, so you have got your answer. That is your answer. A equals to c equals to 1, b equals to 2. Right. So that is the main concept, is that lowest term, lowest power of x should be x square in the numerator for the limit to exist, and not only exist, it is also finite. A finite number 2 is given. Okay, fine. So we've done that question. Now this is the second question. So let us first see which kind of indeterminate form this is. Okay, so as x tends to 0, okay, as x tends to 0 plus means positive towards right hand side limit. Okay, o plus 0 plus. So here you can see that 0, the form I will first see 0, this is 0 into ln of 0, sin 0 is 0. So as x tends to 0, ln x tends to infinity. Okay, so infinity, so 0 into infinity. So now how we will do this? We will do this by, as I've said, that you have to convert this to either 0 by 0 or infinity by infinity form so that you can apply L'Hopital's rule. So how I will do? I will do like this. Ln sin x by 1 by x. Why? Because this will be infinity. This tends to infinity, numerator tends to infinity, denominator also tends to infinity. So infinity by infinity form. Now I can apply L'Hopital's rule. Okay, so now it has become very easy. Apply L'Hopital's rule. It will be 1 by sin x into cos x, and differentiation of 1 by x will be minus 1 by x square, that is minus x square. Okay, so this will be equals to, limit, okay, 0 plus means x tends to 0 plus tan x, no, x square by tan x minus x square by okay. So if you differentiate it once more, both the numerator and the denominator, we get 0 by 0 form. So 2x by tan x का differentiation होता है 6 square. So now you can see that this will be equals to 0 because this is 0 and this is 1. So answer is 0. So your answer would be 0. It is easy. You have to just convert it into the 0 by 0 or infinity by infinity form so that you can easily apply the L'Hopital's rule. Okay. Good. Now next question. Yeah. Okay, so this question is a very good question. First we see that what is the indeterminate form that the limit is approaching. So as x tends to 0, numerator the value, this value tends to 1, and the power, the exponential term sin x by x minus sin x, this tends to infinity because you can see that as limit x tends to 0, sin x by x minus sin x tends to infinity, right? So 1 to the power infinity form. So now we have learned from the formula that as f of x to the power g of x tends to 1 to the power infinity, we can write this as e to the power limit x tends to 0 f of x minus 1 into g of x. So here f of x is equals to sin x by x and g of x equals to sin x by x minus sin x. Okay. So f of x minus 1 into g of x. So now you can see that this term actually get cancelled. So it will be e to the power limit x tends to 0 sin x minus x by x into sin x by x minus sin x. So this term and this term is getting cancelled, and you can get e to the power limit x tends to 0 minus sin x by x, which is equals to e to the power minus 1, because if you can take this minus outside, so minus limit x tends to 0 sin x by x, which will be 1 to the power minus 1. So option A is the correct answer. Easy question, you just have to remember the formula. Okay, and you have to see that the limit is tending to 1 to the power infinity also. Just you cannot just apply it. Okay. Now next question. Next question is also a very good question, and it is also, I think this will also tend to 1 to the power infinity only. Okay, see, yeah, 0 to the power x, 0 to the power x, a to the power 0, b to the power 0, c to the power 0, sorry, x tends to 0, right? So it will be a to the power 0 plus b to the power 0 plus c to the power 0 by 3, that is equals to 3 by 3, 1. So this tends to 1, which will be your f of x. And g of x, g of 0, g of x is 1 by x, so g of x tends to not exactly equal, because limiting value tends to infinity. So this is also 1 to the power infinity form. So let's do the solution. Directly you can write it like e to the power limit x tends to 0, this entire thing minus 1, so a to the power x plus b to the power x plus c to the power x by 3 minus 1 into 1 by x, right? Now see, there is a trick. Okay, when you will take the LCM, what you will get? A to the power x plus b to the power x plus c to the power x minus 3 by 3, right? Now how I will apply this, you see, this comes due to pure practice, okay, and brain, you have to apply your brain as well. This minus 3 I will write like this, e to the power x minus 1, ऐसे मैं इसको डिस्ट्रीब्यूट कर लूँगी, देखो माइनस 3 को मैं माइनस वन लिख सकती हूँ, और ऐसे करके फिर बाई 3 1 by x. Now this can be written as a to the power x minus 1 by x plus e to the power x minus 1 by x plus c to the power x minus 1 by x and 1 by 3. So you know that this is equals to what? ln A, standard formula. This is equals to ln B, and this is equals to ln C. So what are we getting? We are getting this as e x to the power 0 ln A plus ln B plus ln C is ln A into B into C, and 1 by 3. This can be written as e to the power limit x tends to 0 ln A B C to the power 1 by 3, property of log, and now this will be equals to e to the power ln A B C to the power 1 by 3. Now again, by the property of log, you can say that this is equals to ABC to the power 1 by 3. So this is a very good question, very good question. This type of questions are actually given in the exams, okay, because in your JEE Advanced, WebG, all sort of competitive exam will give this type of questions, because these are tricky questions. And also, you see, you don't know or require a lot of steps. I have written in so many steps because for you to understand, but you don't need. You can just skip this step, this one, and also this one. So in 3 steps you will get, but also a very good trick that you have to distribute this 3 into -1, -1, -1. It's a very very good question. Okay, so yeah, this is all for today, and we have completed a lot of part of limits, and only a few things are left, that is infinite limit and limit as integration as a sum of infinite limits. All those things are only remaining, so we will do that in the next lecture. Okay, thank you.